Hello, and welcome to our lesson. As educators, we know the importance of sparking curiosity in our students. Today's lesson revolves around our incredible solar system. By the end of today's lesson, participants will be able to learn how to teach students about our solar system, apply 3 engaging teaching strategies for space exploration, and lastly, learn how to effectively manage and conduct collaborative activities by applying strategies for managing group dynamics and fostering a positive collaborative learning environment. Today, we're diving into an engaging lesson designed to captivate your students' curiosity about our solar system. We'll start off with this brainstorm question. What comes to mind when you think about our solar system? Ask your students this. When you think about our solar system, what images or ideas immediately come to mind? Encourage them to think beyond textbooks and share their initial thoughts. Explain the process of brainstorming by explaining that this strategy is a creative technique where we generate a variety of ideas without judgment. And emphasize the importance of open-mindedness and encourage every student to contribute. For this brainstorming activity, we'll provide one method of delivering the activity that could be applied in your classroom. Since different schools have access to different tools, we could use a variety of different tools, such as the use of technology. We could allow the students to use Jamboard or other methods that this teacher might think is better for their own classroom. So for this activity, we'll have questions written on the whiteboard all around the classroom. The questions vary in difficulty to engage those students that might think it's too easy or those students that might think it's challenging. We will provide the students with sticky notes, then ask the first question. What planets can you think of? We'll proceed to give them some time to write their answers on the post-it notes, then ask them to place them under that question. Then the second question, what does space feel like? We'll do the same, and then we'll move on to the third question. What does space look like? Now we'll move on to the more challenging questions here. What keeps planets together? What conditions are necessary for life? And lastly, is there life outside our planet system? Here are some of the answers your student might come up with. Proceed to discuss what they have written on the board, as well as answer any questions that they might have. In conclusion, strategy number 1, brainstorming, is a powerful tool to engage students in thinking about the solar system. As educators, we play a vital role in nurturing their curiosity and fostering a lifelong love for learning. Continue to encourage exploration and curiosity in your classrooms. After sparking curiosity in your students in regard to space exploration, you can now begin a brief lecture about explicit terms they would need to understand from the curriculum. For example, you could show them an acronym to help them learn the order of the planets in our solar system. Or you could go over terms that did not come up during the brainstorming activity, but still have to be covered.
After using a mind map tool to assess the understanding of students about classroom knowledge, the second strategy is the craft framework. The objective of the craft framework is to provide a list of guiding questions or criteria for students when they are selecting literature, including news articles, scientific journals, or videos, and evaluating the literature's reliability and credibility. It's vital to evaluate the validity of literature, as this process is closely related to critical thinking. Moreover, unreliable or biased source of information can lead to poor judgment or decisions. The craft framework can be divided into the following 5 components: currency, relevance, authority, accuracy, and purpose. The following worksheet can be used as an aid while introducing the new concept. It puts the student in a scientist's hat, allowing them to interact with the lesson and expand on prior knowledge.
We have created a sample worksheet that can be used as a resource and given to students while teaching them the CRAP framework. Feel free to use this worksheet while introducing the literature review and comparing the 2 news articles later in this presentation. The worksheet introduces students to looking at literature from a scientist's point of view and guides reading following the parameters of currency, relevance, authority, accuracy, and purpose. The pages are intended to be used for students to summarize key points and identify CRAP characteristics from each paper.
The first question, or the C in the craft framework, is when is the text released? If the text is written over 10 or even 5 years ago, the discovery or data or supporting information may be outdated and hence not applicable anymore. The second letter in the craft framework stands for relevance. Relevance asks if the student or presented information aligns with students' topic of interest. We can ask questions including what happened during the article. Can the text answer my question? Furthermore, as the student are emerging scientists, students also need to ensure the paper aligns with their level of knowledge, which students should ask themselves if the text matches their difficulty. If the student finds a journal in which the intended audience is for the expert in the field of space exploration, they may have a hard time understanding the text. For example, in a diagram of spacecraft, it contains terminology such as anti-vertex siphon. The student may be confused about their functionality or even meaning. The third component of craft framework is authority. When selecting text, we want to select people that we can believe in, and hence we need to check their credential. To understand the authority of the text, we need to ask who or what organization wrote this text. Where does this text happen? Does the person who wrote this text have sufficient background knowledge about the current issue? Are they expert in the field? We also need to ensure that the paper does not have any potential conflict of interest. For example, if an oil and gas company is funding environmental research on the impacts of oil and gas, it can be biased. Next, we need to consider accuracy. Accuracy means that we need to consider questions like, can I find evidence such as empirical data in the text to support author's argument? Is the text verified? Can I find other texts that support the evidence? Is the writing just neutral, or what is the tone? Is it biased? By answering those questions, we ensure that there is sufficient evidence to support the rationale of author's points of view. Last but not the least, the last component of the framework is purpose. We need to consider why the writer wrote the text. Various purposes of literature can lead to different outcomes, such as informing, pursuing, entertaining, or selling. For example, company research may invite stakeholders rather than sharing knowledge. Furthermore, we need to consider the information if it's facts, opinion, propaganda, and most importantly, who will benefit from the text. At the end of craft process, students are given 2 examples to analysis. We can follow up craft framework by asking the following questions. Based on the context of the article, do you think there's anything missing? If you are the author, what would you add or remove from the text? Is there any new information you have learned from the text? The author of the text approached this article from the point of view of a scientist. Can I approach this problem or from another point of view? Now, please stop the video and have a look in the following 2 articles. Please use the craft framework to determine if the article is suitable for grade 9 student for the topic of space exploration.
Let's analyze these articles together. The first article was published in 2021, which means it's relatively recent, just 2 years old. Considering its relevance to grade 9 topics, it aligns well with the distance-related subject matter and touches upon elemental compositions like iron and nickel. Grade 9 students should possess an adequate background knowledge to comprehend this article. Although the journal was authored by a journalist, the claims made are substantiated and connected to research. Upon reviewing the website Forbes, it was evident that Forbes focuses more on the business aspects of events, biasing the article with its emphasis on mining metals for profit. On the other hand, the second article was published in 2004, nearly 19 years ago. It was written by Leonard David, a seasoned reporter in space exploration for over 50 years. The article aims to debate the balance between the cost and potential benefits of scientific research in space. It incorporates the viewpoints of James Van Allen, a pioneer in space exploration, which carries considerable influence and authority. However, the data or costs related to space exploration cited in this paper might be outdated. It's objective to encourage readers to reconsider the necessity of space exploration for the betterment of human society. Comparing the 2 articles, each holds its strengths and limitations. The first article is more recent, whereas the second is penned by experts in the field. Yet we'd lean towards the first article due to its more recent nature and potential for linkage to other research papers for supporting evidence. Additionally, the second paper lacks clear references for the data concerning space exploration.
Picturing in your mind how large our solar system is can be an extremely difficult task. Even adults don't understand what a light year is or how to represent the number 1 billion in their mind. So, to understand quantitative measurements, modeling is an excellent teaching strategy to use. After students learn how to select proper research articles for the information they want to present, they may learn how to model that information. For a solar system project, one option would be to model the distance between each planet within 5 meters. This requires them to exercise their scaling abilities, unit calculations, and conversions as well as creativity. Make it clear to the students that the size of the objects they select to represent the planets in the solar system does not have to be a scale representing the true size of the planet. Here's how our group completed this task. To begin, we identified the distance between planets and then used unit conversions of 12.5 centimeters as one astronomical unit to scale it down to fit in 5 meters. Next, using a measuring tape, we mapped the distance in a linear model on the floor. We used identical coins to represent each planet and identified them with labels. The scale factor depends on space availability. A full classroom or the distance of a school hallway allows students to format different understandings of magnitude. An option to extend the complexity of the task would be to choose relatively sized objects to represent the planets. This is one way of showing students to use modeling in their learning.
Expanding on the extension mentioned above, an interesting alternative model of scale would include the size of planets in space. Students have reflected on questions from Strategy 1, and we may ask students to discuss again what does space look like, based on their expanded understanding of how big the universe is. The previous model was intended to get students to visualize distance and potentially struggle to conceptualize the magnitude of the measurement. With this struggle, they now understand how far apart the planets are, and we as teachers may build out this understanding to the size of planets. Using common objects, we may begin to model this, and students can see the relative size of objects in space. An example of this would be as follows. Using fruit, where the smallest planets, such as Earth and Venus, are cherry tomatoes, and the larger planets like Jupiter are a watermelon. Using this model of scale, the sun could not be conveyed with an object. Rather, its magnitude is so great, it would be the size of a 6-meter cargo container. These modeling systems have led us to consider other interesting ideas of models, such as using the weight of Earth and referencing it to the weight of a can of cola. We could ask the students to consider the weight of other planets in cans of cola. For example, the sun-to-Earth ratio would be 333,000 cans of cola. Do you know how heavy the sun is? Even when we add up the weight of all the planets in the solar system, it would still be lighter than the sun.
Thank you so much for watching. You have made it to the end. To recap, here are all the strategies you have learned today as a teacher. You now know how to properly conduct a brainstorming activity. Keep in mind where you place the questions around the classroom as well as their difficulty. You also know how to help your students select the proper article using the CRAP framework. Remember to show them a contrast between what is considered a valid and an invalid source of information. Finally, you have learned how to teach your students about the importance of modeling. Hopefully, with the model yourself, as well as your students, will understand just how massive and complex our solar system is.
Please see the attached list of references utilized to support the content of this video. This presentation was created using Canva. Thank you for listening.